Hello all, I am Vasanth, Azure Associate Administrator. This project done by me. Find the linked link in the description box. Now, what we're gonna do is, by using Terraform, I deploy resource group storage account, container and some object in container in Azure subscription. And also I gonna use a free lightweight powerful source code editor called Visual Studio Code to use Terraform extension for better coding experience. So everything we're gonna deploy automatically using Terraform only. But I don't have any VM or server, so I am going to deploy virtual machine on Azure. While deploying virtual machine on Azure, I'm on the way. I'm going to install Git Terraform Visual Studio Code by using the run command on the Azure portal. With the help of installation script generated by Gemini AI tool, I use the Gemini AI tool to generate the installation script. So with that installation script, we can automatically deploy the Git, Visual Studio Code, and Terraform. Because it takes time to install this Git, Terraform, and Visual Studio Code one by manually. So I'm going to use this script which deploys or install the Git, Terraform, and Visual Studio Code within a less time taken in virtual machine. So now I'm going to configure virtual machine. I use 20, 25, 2025 Windows Server image. Uh, two, C- uh, 2 CPU and 4 GB RAM. Let us create the username. So password is given. Next we have to give inbound ports. So I'm going to allow HTTPS port also. HTTPS and RDP. And in networking, we have to choose the public IP. I choose internet. So the it will traverse through the internet, the public IP. Everything is fine. Going to run and create. Deployment is in progress. And I will show you that in Google Gemini AI, I generated a script to automate the installation of Git, Visual Studio Code, and Terraform. I tried even AWS also. It's very good. It's very fine. So this is the prompt which I given. So for this prompt, I got the script. So this is the bootstrap script. Now I'm going to copy this script. Now I'm going to paste this script in the Azure run command. So inside the virtual machine, there is the option called run command. There run PowerShell script. In PowerShell script, I'm going to paste the code. I paste the script. Now I'm going to run. So this script will install Git, Visual Studio Code, and Terraform. Now I paste the script into the run command. In background, it's going to install the Git, Terraform, Visual Studio Code with the help of installation script generated by Gemini AI. So you can check the time also. It's 5:10, and it will get installed within 5 minutes, like 5:15. And an installation script automates the process of setting up many tools on the Azure virtual machine. It takes care of running the necessary commands behind the scenes, so you don't have to do it manually. This script uses Chocolately, a package manager for Windows because it is the most reliable way to handle unattended installations of software like Visual Studio Code and Terraform without needing to manually handle in MS URLs or GUI, graphical user interface wizards. So it ensures the system knows where the new tools are located without needing a rebooter. So you can run the script even in the running virtual machines. So the same process, even its work in the Terraform works. The same method, this method also is used by the Terraform. So the Terraform is an infrastructure as code IAC tool built by HashiCorp. Instead of manually clicking through cloud portals like AWS, Azure, or Google Cloud, to build servers and networks and databases, you can write the configuration first that describes the infrastructure you want. So Terraform is a declarative tool. You tell Terraform what you want to finally outcome to look like. For example, I need 5 images and a load balancer. Terraform figures out the steps to make it happen. So it is also a cloud agnostic tool. It uses a single consistent workflow to manage infrastructure across dozens of different providers, including the major clouds like AWS, Azure, and GCP as well. It also works in on-premises systems like VMware also. So Terraform is the consistency and automation tool. By defining infrastructure in code, you can version control it, share it, and deploy the exact same setup repeatedly without any human error. In short, Terraform turns manual cloud infrastructure management into automated, repeatable code. It handles the complexity of creating nested resources in correct order, say as like Azure subscription. From Azure subscription, we have resource group. From resource group inside storage account inside container inside a blob object. So the process involves creating a set of configuration files and running in the standard Terraform workflow. So this is the process of deploying in Azure Resource Group, Storage Account, Container, and Blob using Terraform, often performed within the Visual Studio Code. So install the Terraform and Git Bash or PowerShell. Make sure both tools are installed on your machine, and authenticate it using Azure CLI, or you can authenticate using the app registration in Azure portal. So Terraform uses the authentication via the app registration for the credentials to manage the resources. So the virtual machine uh, can be controlled with this Visual Studio Code workspace. Created a new folder or your project and open it in Visual Studio Code. So you can see that whatever the blocks, so what are the blocks we have pasted in the Visual Studio Code in the file, the same will be replicated in the Azure portal. Now its time is 5:15. I think now it's going to finish. Let us check. Yeah, now it's finished. You can see the output. So what work the command has done. You can check the output also. Install of VS Code is successful. Uh, Terraform installed successfully. Git Git version 2.52 Terraform. Everything is successfully installed. Visual Studio Code also. Now we'll check on the server. Now I'm going to take RDP connection. You can check in there is only two resources group. One is test and is network voucher RG. I'm going to copy and paste public IP. The public IP is connected to internet. So and the password is given. So which machine is running successfully. You accept. You can check the Visual Studio Code is installed successfully. Now I'll check the Git bash whether git bash is installed or not. Yeah, git bash is also installed successfully. Now next we have to check for Terraform. Yeah, Terraform also installed successfully. Now next we have to go for configuration for a Visual Studio Code. I close this. I change the theme color. And this color is also good, but I try some different color. Think now I think this is fine. Now we'll going to install the extension for Terraform. So in Visual Studio Code we'll be having varieties of extension. I'm going to use a Terraform extension. There is a two extension. One is this HashiCorp Terraform extension. Another one is Microsoft Terraform. I'm going to install this HashiCorp Terraform. Now I'm going to install this Microsoft Terraform extension. This is nothing but this extension helps like instead of manually creating the command, it will prompt like when we use on Gmail. So it already gives a script that we want to use command. I will show you. I'll tell you while creating. Now I'm going to git bash. I'll check once the Terraform is working or not. I'm going to change the font so that we can visible. Now font is visible. I check the version Terraform -v. Now you can check the version. If it shows the version, I think Terraform is working fine. The application is installed successfully. Now I close this git. Now what I'm going to use the git via Visual Studio Code. We can use either PowerShell also, but Git is a little friendly to use. So I'm going to use the Git. I will show you how to use the Git in Visual Studio Code. First of all, we have to we have to select a folder. So I'm going to select folder as a desktop. Yes, trust the author. You can see the screen we have split. So the below one will go for Git bash. I'll delete the PowerShell. Git bash is more friendly to use more than PowerShell. And I close this. I give control plus to give big fonts. I think it is visible. I'm going to create a folder in this desktop mkdir Azure, and I'm going inside the folder Azure. Inside the folder Azure, I'm creating a file called deploy.tf. Deploy is a file name and tf is a extension name, Terraform. tf Terraform. Now I'm going to edit this file. So on the above section, you can use for editing the file. Below is for using the git bash. Above is for file editing interface. Below is for command line interface. I'm going to use Microsoft Edge browser to use Terraform registry. So, this is the Terraform registry where multiple cloud providers are available here. You can see AWS, Azure, Google Cloud, Kubernetes. So more providers here. I'm going to select Azure. Here I am going to copy this script Terraform. This is especially for Azure. So I'm going to paste in the file editing interface section. Here in this section we can edit the file. I here actually in this configure section we have to give subscription ID, client ID, client secret, and tenant ID. So you can just click CLI. The remaining part we will get here. So this is the extension. This is the benefits of the installing this extension. Just entering C, we'll get the prompts all what to. So you can select there. For a desired command, you can select. For just I'm entering T, I'm getting this old command. This is the benefits of installing the extension in the Visual Studio Code. And features. Features is for mm, any features. We can leave blank the features. No worries. So for subscription ID, I'm going to copy from my portal. So I copied the subscription ID. So the same I will going to paste in the subscription ID section. So this will be used for authentication portal. Now in client ID, For client ID, we have to install the app registration. Now I'm going to Microsoft Enter ID. First, I'll copy the tenant. Tenant ID is available here. So I'll copy the tenant ID. I will paste it in this file. Now for client ID, we have to register app. So Terraform is also an application. So we'll create an application app registration in Microsoft Enter ID. So I'll give a name as a Terraform, new app. So I'm giving permission to the Terraform app. So the Terraform can install whatever we want. So you can see the application ID, application client ID. So this one you have to copy and paste it in the client ID. Next, client secret. For client secret, we have to go for certification and secrets. I'm going to create a new client secret. This is a secret ID used by Azure. So new secret, Terra. And you can give expiration date also and choose only 90 days. That's enough for me now. Now I'm going to add. So we will get the client ID also, client secret. So we got all four. Be careful in client secret. We have to copy the value only, not secret. Now in documentation, now I'm going to create a resource group. For that, I want uh, script. So I'm going to copy this code and I'm going to paste here. This is deploy RG1. This is not the resource group name. It is just the deployment name. This is a block. For this block, the name is deploy RG1 block. And the name I give, this is the resource group name I given as the Azure RG1. And location, you can choose Central India also. You can give any name for resource group name. So this is separate block. The next block I'm going to add for a storage account. Storage account. See in this script, even the resource groups also is there. Resource group, storage account, container, blob, everything is there. If you want, you can copy the whole thing, and after that you can edit whatever you want. In a single template, we'll get all whole script. I'm going to paste here. So you can see the block for each block will be having the storage account, and another block is the storage container, another block is blob. But right now I don't want this container and blob. First I'm going to install the storage account. After that, if you want, we will add script again. This name, resource group name, location, account replication type is this is called as an argument. The above one is called as a parameter. In double quotes, whatever is there is a parameter. This deploy storage one is the name for the block given to the storage account, and the name is the storage account name. I'm giving name as a Terra storage. This name should be unique because if a similar name is identical, it won't get installed. It won't get deployed. So Terra storage I have given. In future, if you want to change the name, you can change the name. Now for resource group, Terra RG, like what the name I have given for resource group, that name we have to give. Azure Terra RG. Azure Terra RG1. Look for location, I choose the central India. Accounter, let it be standard, and accounter replication type, let it be LRS. LRS is a local redundancy storage. Actually, this storage account name should be unique. But let us try. If you want to, we can change. We can change afterwards later. But make sure that it should be unique. Unique name. Nobody should be used that name. So this is the whole script. Each is in a block, separate block. This is the whole template. Now what I'm next, I'm going to deploy this. First, I want to use the Terraform in it. So Terraform will be initialized. So we have to initialize the Terraform. This is the command to initialize the Terraform. Terraform has been successfully initialized. Now we leave Terraform, validate to check whether the given script is validate or not. No, it's showing some error. It is showing that you have to use lowercase letters and numbers must be between 3 and 24 characters. So I told you that the name should be unique. I'll give another name for the storage account name. We'll try different name. So I change the name. Now I'm going to validate this again. So you can see the configuration is valid. Next, we have to choose for Terraform plan. Terraform plan is like what is the output of the script. So this is will be output. So again we have some get error. So it is showing that it does not have authorization to perform action. You can see that we have not given permission to perform action in the Azure portal for this Terraform because we have to give another special role for this Terraform application. In Azure, it's like that only. So for we have successfully created app registration, but even though we have to use some IAM rules, IAM roles. So for that we have to go for subscription. In subscription, we have to choose access control IAM. Here, what we have to give permission for the Terraform app application. So add role assignment. Here we are in privileged administrator. I'm giving owner role. and in members I'm going to add that Terraform application. This Terraform application acts as like service principal. So this is actually a service principal managed entity. Managed entity or user groups or anything we have to give can give, and conditions I just give allow users to create storage account. Now review and assign. You can see the adding rows as assignments for this Terraform service principal application. Now again we'll try Terraform plan. It will be in backend. It will be calculated. So this script, what can go to extend, what can do from this script, everything. So it's showing that we can add two resources, zero to change, zero to destroy. So the plan is successfully validated. So next step we have to give Terraform help. Now actually Terraform help I'm using to know what and all keys are there. Terraform applies for to initiate the deployment. I'll check for again deployment Terraform apply help. So here in this we can see the auto approve option. This is like in between it will ask for each block yes or no, yes or no, yes or no, like that. So if you use this auto approve, we no need to give one by one yes, no, yes, no, like that. We can it will be automatically take approve and it will be deployed. So Terraform apply auto approve. Or else you can give only Terraform apply. You can see the Azure RM storage account deployment is creating. You can see the creating storage account. It is showing the already our Terra storage 303 also is there. So I'm going to rename again for the storage account. But resources group is successfully created. Only thing issue is with the storage account name. So I'm going to change the storage account name, and again I'll try to deploy. I give access to our storage 303. I'm going to save this file. After saving, I'll run again the command terraform apply auto approve. You can see the storage account deployment is creating. So only the name should be unique. If it is if it is not matching the name, we have to give another name. Once the name is allocated correctly, you can use the same template again and again. No issues will be there. You can share this template to others so they can deploy the resources without going to the portal. It will always work in automated way. This is a storage account is deploying. Apply computer resource one added. So we'll get some errors when we troubleshoot the errors. So next time it won't show any errors. We can use how many times we want. Initially we will get errors only. So next time we can use this template. So you can see without going to portal, resources will be installed here, will be deployed here. You can see the Azure Terraform resource is deployed inside storage 303 is there. They can see and container also is there, but in container nothing is there. So we are going to create a container, and inside container we are going to create a blob, an object. We can use the same template as it is directly by using depends on. By using depends on, we can deploy everything at single time. By using depends on that, I will show you in another video. Next video we'll try to deploy on virtual machines, virtual networks, subnets, storage, everything at a single click. But now it's just a basic. I will show you how to do. I'm going. This is the container deploy name. The next for next argument I'm giving as container name. I'm giving as a very important data, or else we can give confidential data. Any name we can give. And for storage account ID, we have to give the storage account ID which we have deployed previously. In endpoints, we'll get the storage account ID here. We can copy here, or else we can copy here. Another way is there. Another way we can copy the storage account ID in this JSON view. template. I'm going to copy here. We can copy here also or there also. Anything is fine. Now we have to paste here, but it should be with a double quotes. I'm giving object so which object I'm going to upload. I'm going to upload a file. This is the same file what we have deploy.tf. So the file which we have created, the same file I'm going to upload in the storage account container. Or else we can upload anything you want in any servers where we can move it. The same file we are going to upload there also. Deploy.tf. Now I'm going to save. Now I'm going to validate also. Say Terraform plan. This is not compulsory. You can directly go to that Terraform apply. So no issues. Everything is fine. Now I'm going to auto approve Terraform apply. See completed. Two resources been added. Check in the portal. In containers. If we check, see you can container is created, and inside even a file also is created. If you check the file has been successfully uploaded. So everything is successfully created. So this is a template. We can just copy this template and we can use whenever we want. We can use we can deploy multiple number of virtual machines, storage accounts, multiple number of containers, anything we can create from this template. Next time I will try to deploy multiple VMs, multiple VNets, multiple subnets using this Terraform. And finally, to remove whatever we have deployed, for that the command is terraform destroy. So this command will remove everything what we have already deployed. So it will ask the value. So I'll give S. You can see the four resources has been destroyed. The four is the resource group, storage account, container, block. All four is removed. So we have seen without going to the portal, we have deployed resources and removed resources also by using the Terraform. So this is the use of Terraform. Still, there are many usages on Terraform. This is a sample to use the Terraform, but there are more to learn about this tool Terraform. You can see many templates are there. So we can next time we'll try to deploy virtual machines, multiple virtual machines, multiple virtual networks, multiple subnets. We'll try to do next time. I will show you that we have removed resource group, storage account, and container blocks. I will show you in the portal. Once we do refresh and we check the resource group, you can see there is no that Azure Terra RG resource group. It has been removed. There is no storage account also. So automatically it get deployed. Automatically it get destroyed also. So thank you for watching this video. We'll see you next time. Bye.